This is video number 5 for sections 3.3 and 3.4, QVT problems, mixture problems. This is the final type of QVT problem and probably the trickiest. We're dealing here with chemistry mixture problems. Let me give you some background before we hit the real problem. This kind of phrase shows up a lot in these mixture problems. Somebody has 10 ounces of a 40% lime juice solution. I just want to make sure you understand what this is saying. The 10 ounces means somebody has a container and the total liquid in the container is 10 ounces. But the word solution means that that liquid is made up of two parts. A chemical, in this case lime juice, mixed with water. So when you read solution, it means you've got some chemical and some water. Now the question here is, well, how much of this 10 ounces is lime juice and how much of it is water? Well, this is where Q times V equals T comes in. In these mixture problems, Q always stands for how much liquid you have. V, the valuation, is the percentage you're given of the chemical. And T, the total value, stands for the total amount of the chemical in your solution. So in this problem, if I take my 10 ounces, that's the liquid I have, and I multiply it by the percentage, 40%, now I'm going to write that as a decimal, 0.40. The answer I get will represent how much actual lime juice is in there. And you can check this on your calculator. It comes out to be 4 ounces. In other words, in this 10 ounce liquid that I have, 4 of the ounces are lime juice, leaving of course the other 6 ounces to be water. Now really it's all mixed in there together, but that's where it came from. The point is, if you take the liquid and multiply by the percent, you get the total amount of chemical. Here's a second background question. What if we took this container that we had here and we mixed it with a second container that also had 10 ounces, but it had a stronger solution in it. It had a 60% lime juice solution. What would we end up with? Well, there's kind of two issues to talk about. Let's first think about the total liquid that would be in the container. This guy had 10 ounces, this other guy had 10 ounces, so that would mean 20 ounces total of liquid. Of course, some of the liquid is lime juice, and some of the liquid is water. If in this second container the solution was 60%, I could figure out how much lime juice by doing a similar calculation. It would be total liquid multiplied by the percentage, 0.60 as a decimal. If I go to the calculator, that comes out to be 6. So in this second solution, there are 6 ounces of lime juice. In the first solution, there were 4 ounces of lime juice, which means in my total, my mixture over here, I end up with 10 ounces of lime juice, leaving, of course, the other 10 ounces to be water. This one is now half and half, right? It's half lime juice and half water. That would mean that this is a 50% solution of lime juice. Okay, so with that as a little bit of background, let's head to the actual problem here. Again, we'll just set up the equations. So now we're moving from lime juice to antifreeze is our chemical here. How many quarts of a 16% antifreeze solution and a 24% antifreeze solution must be mixed to make 8 quarts of an 18% antifreeze solution? I need to pick two variables to represent the unknowns. I always do the same thing in these mixture problems. I always use W and S to stand for the amount of the weaker solution and the amount of the stronger solution. The idea in these problems is you've always got a weaker one. In this case, the weaker one would be the one that only has 16% in it. and then you've got a stronger one, that would be the one that has 24% in it, and you're mixing them together and you're going to end up with something in between. In that last example, that background problem, we ended up with exactly halfway in between, didn't we? Because the original one was 40% and then we had 60%, we ended up with 50%. That does not usually happen. That only happened because we added in the same amount of liquid both times. In our problem down here, clearly we are not ending up halfway in between. We're ending up with an 18% antifreeze solution. That's pretty close to the weak one. So I'm thinking our mixture is going to be mostly weak with just a little bit of the strong one thrown in. In any case, when I go to the table, of course my two rows are just going to be weak and strong. Now I can start filling in the boxes. Remember, in a mixture problem, the Q stands for the total liquid. How much total liquid do you have of the weak? Well, that's what I don't know. That's what I'm trying to figure out. I have a name for it. We called it W. How much total liquid do I have for the strong? I don't know. We're calling that S. The valuation in these problems, the percentage. And so don't I have that? Yes, the weak solution 16%, so I'll write 0.16. The strong one is 0.24. And the T, the total, stands for the total amount of chemical in your final mixture. Remember, I don't have to think about what to put here. I just multiply across as we've been doing. So I'm going to write 0.16W and 0.24S. And then it's time to start writing equations. I'm expecting to get a quantity equation, and I'm expecting to get a total value equation. The quantity refers to the total amount of liquid. So I'm looking in this problem for something that has to do with the total liquid, and I think the only thing mentioned is right here. In my final big container, when I mix these two things together, I'm supposed to end up with 8 quarts in all. That's a total. Total makes me think add. So my first equation is simply, look, if you take the liquid from the weak one plus the liquid from the strong one, you're going to end up with that 8 quarts in all. Maybe it's 6 quarts and 2 quarts, or 3 quarts and 5 quarts. I'm not sure yet. But the total of those two liquids has to be the 8 quarts. Okay, then I come over here. Now this is where it gets just a little bit tricky. Remember, this box here stands for the total amount of actual antifreeze in the weak container. And this box stands for the total amount of actual antifreeze in the strong container. Well, if I add those two pieces together, I should get the total amount of antifreeze in the mixture. Let's think about that. So, total antifreeze in the weak plus total antifreeze in the strong equals the total antifreeze, not the total liquid, the total antifreeze in the mixture. Now, the reason this is tricky is they didn't tell me the total antifreeze in the mixture. They could have been nice and said, oh, you should end up with 3 quarts of antifreeze. Okay? They're making me calculate it. Here's what I know. I know there's 8 quarts of liquid, and I know the percentage in the final mixture is 18%. Well, to get the amount of antifreeze, I have to do the same kind of calculation I did for these two things. I have to take the amount, the 8 quarts, and I have to multiply it by the percentage. 8 times 0.18 represents the total antifreeze in the final mixture. This is a little tricky. The good news, it works this same way really every single time. So when you're going through the homework, have this out in front of you. Of course, the percentages are going to change and that sort of thing, but the same idea goes from problem to problem. With this problem here, you may want to finish off solving the system. I would probably go with method of substitution. I could easily get one of these two letters by themselves and then substitute. Elimination would be okay. You'd just have to work with a lot of yucky decimals. One of the first things you would do, of course, is just multiply these two numbers together. If you solve it and you want to check your algebra, you should end up with S equals 2 and W equals 6. In other words, we're mixing 6 quarts of the weaker one with 2 quarts of the stronger. As we suspected, we're using more of the weaker than the stronger. Be sure to practice these problems on the homework.